Today we're going to talk about physical changes versus chemical changes. Firstly, let's define what a physical change is. A physical change involves a change in a shape or a state of a given substance. So say we light our Bunsen burner and it melts this ice cube. The ice cube turns into water, which can be collected in a beaker. Now what's happening is that the water molecules, H2Os, are spreading farther apart. Because in a solid, particles are condensed very close together, whereas when it gets into a liquid, there's more space between them, and then as a gas, there's even more space between them. But the key here is they're all H2O. You're noticing that every single molecule has two H's and one O. Two H's, one O, two H's, and one O. A really great way of seeing this is in this video. So we're noticing that solids are very closely packed together. Liquids are a little bit more space between them, and then as a gas there's lots of space. And actually you're noticing that the speed changes too. Let's just look at this. The gas is moving the fastest. Okay, now you're not seeing it in here, but these little guys are just vibrating. They're vibrating. They're not moving, just like the liquid and the gas are. But in a physical change, particles move closer or farther apart, but particles stay the same. Water is just water. Now water can have different states, but so it can be in ice form, it can be liquid form, it can be in water vapor, but the particles are all H2O. So in a solid, all of the particles are very close together, very densely packed. Whereas in a liquid, there are a few more gaps between them. And in a gas, they're very far apart. Now you're noticing in this there are more molecules represented by the blue dots than in the liquid or the gas. It doesn't mean that there are more or less, but just in this space they would be more densely packed, so we see more of them. Now a chemical change. A chemical change is when a substance with new properties is formed. This is through a chemical reaction. The particles change. So in a physical change, the particles stay the same, whereas in a chemical change, the particles change. There are 5 indicators for a chemical reaction. So first of all, we have a change in color, we have a change in smell, and just from a safety standpoint, don't stick your nose into a beaker or anything like that. Make sure that you use a safe wafting technique. The other thing that we can see is a fizzing or bubbling. This is a releasing of gas. Now if you take any acid and you put a metal in it, it will produce a hydrogen gas. So that gas comes off in the form of bubbling and fizzing. You could potentially see a change in energy, and I don't mean like in kind of a more metaphorical way, oh, your energy has changed. I mean like it gives off a light, or it gives off heat, or it gives a sound. Hydrogen gas, if you light it, actually makes a whoa! It kind of sounds like a dog barking. It actually makes a sound. So you can tell if the container feels warmer than heat is released. That's called an exothermic change. It means that exo, like when we're talking about the roots of the words, exo means heat. Sorry, exo means out and therm means heat. Another thing is that the container could feel cooler. That means heat is literally absorbed from your hands or from your fingertips. This is an endothermic change. So when you do your lab, what I want to make sure that you do is make sure you feel the containers, because you potentially could feel a temperature change. The fifth is when two clear liquids are mixed, then a solid forms and the mixture goes cloudy, or the mixture goes cloudy. This is called precipitate formation. Now, these pictures are here to help you because it's pretty uncommon for us to talk about precipitates before grade 9. But if you're looking for a precipitate, it's going to look something like this. Another well-known, but maybe not known that it's precipitate, is milk. Actually, milk is a precipitate because there are solid particles that are suspended in a liquid. So just so that we have a little bit of a takeaway here, a physical change could be ice to water to vapor and back again. Vapor can condense to water, liquid, which can solidify to ice. A chemical change using water. Is electrolysis. It's literally when you take your H2O and you split it. So it becomes oxygen, which always comes, it's a diatomic molecule, which you'll learn next year, plus H2, another diatomic, not diabolical, but a diatomic molecule. So what happens is you take the two H's and one O and it creates H's and O's. Whereas in a physical change, so that's in our chemical change, okay? It means that the particles are different on the beginning as reactants versus products. Whereas physical changes are always going to be, you're always going to have your H2Os. The only difference is that they move closer and farther apart. So physical change, same particles. Chemical change, different particles. So as a summary, physical changes result in change in phase, so solid, liquid, gas. Whereas a chemical change results in different particles.